So I'll record it. Let's do, hope it goes better than yesterday. Catch me if I screw this up. So anyways, this is assignment number 31, and we'll just do problem one together um, and get you off on the right foot. I hope you've got some separate paper out. And what we're going to do, what I'm going to do, what we're all going to do is don't copy all the X's, Y's, and Z's over, right? Like you learned yesterday, we're just going to copy over the matrix, the numbers, the numerical part of the system. So we're going to have a top row of 3, -4, -1. You better keep an eye on me here. I'm not particularly, I'm doubting myself here today. And then a 4, and then a -3, and then a -1, and a 2, and a 4. Then bottom row, -5, -4, -5, and -16. And remember that with matrix notation, you need to use it's math is a language, and you don't get to just say things the way you want. So in math, when you want to express a matrix, you need to put that square tall bracket around the whole thing. That's how people know that you're dealing with a matrix. It's not a huge deal, but it is what it is. So in spite of or despite the dumpster fire nature of that, let's see what you learned. What's our first goal? Good. So I'm going to stay consistent with the colors that I elected to use 8th hour when it was going better. Purple is going to be our worker bee. And so when we have undecided our worker bee row, the first thing we want to do is leave on your paper maybe an inch or so and head off to the right side and rebuild the matrix, but only copy the worker bee row. So the row that's not going to change is the top row. So the 3, the -4, the -1, and the 4 just get copied over. So we'll do this one at a time. So our first target is yellow. And our goal, like Mari said, is to make yellow equal 0. Understand again that as we do this, the top row isn't actually changing. It might have to change itself, sort of, chameleon-like, like change into something, but it's only really fake and temporary. So in this case, nothing really revolutionary. This is pretty light work here, but like when we get to the one on the bottom below it, then we're going to be modifying by multiplying, but we're not actually changing the top row. It's just kind of temporarily morphing and then coming back. So this one should be an easy question. If you can't answer this, then I officially ruined you yesterday. How do we combine the purple and yellow to make a 0? You just literally add them together. So there's no multiplication necessary. So the way we're going to write this one, and remember that we write our row operations next to where the answer will go. That's important. So like by putting it right where I'm moving my pen, I'm telling people that the stuff I'm about to write next to this is the answer to what I'm writing. And what I'm writing is row 1 plus row 2. Row operations don't get any simpler than this one. What a great way to start the day. So we're going to add row 1 and row 2, and every result that we get, we're going to write into row 2. So we're modifying row 2 now. He's going to be a new version of himself. So what's purple plus yellow? Yeah. All right, so mission accomplished. We got a 0. And now as we go through this, we don't need any mental powers here, like that's just right in front of us. What's -4 plus -1? Yeah. And then for the next column, -1 plus 2. And then for the final, the constant column, we have 4 plus 4, which is 8. All right, so worker bee row is still just sitting there unchanged. What we're going to do now is go back to the matrix from before, and we're going to change the red number into a 0. Lost in the chaos yesterday of the big numbers was this. I want to say this again. You cannot use the yellow row for calculations, okay? We only use one worker bee row in every step. And in this step, it's purple. He's my guy. Yellow is just going to sit here now. Okay, we're going to basically skip over him. So what kind of a row operation combination could we do to make purple and red make a 0? It's exactly right. And so we're going to we don't have to modify any signs because purple's already positive and red's already negative. And so we're just going to take 5 times everything in row 1 and add it to 3 times everything in row 3. And again, like I said, I don't care what happens on the other three columns. I'm interested just in the first one. If I make a 0, whatever else happens, happens. So what's the answer to 5 times purple plus 3 times red? Of course, it's 0, right? If it wasn't, then we would be, wasting our time here. This is where it can go bad if we're not careful, but you just have to, do you decide how much do you want to write down? You remember yesterday I started writing numbers down as they got bigger. You can start writing them immediately if it helps you. Lots of chicken scratch work off to the side. So what is 5 times the top row where I'm moving my pen? Negative 20. And then what's 3 times bottom row? Negative 4. Negative 12. If you add those together, what do you get? Negative 32. You okay? Okay. So we move over now to the next column. What is 5 times this negative 1? Negative 5. And what's 3 times this negative 5? Negative 15. And if we add those together, we get negative 20. And then finally, we have 5 times the top row, right where my pen is at. What's 5 times 4? 20. And what's 3 times negative 16? It's negative 48. And if we add those together, what do we get? Negative 28. Now, one thing that yesterday, it got away from me, and I'm always probably overly dramatic about these things. For you, it was probably just another day in math class, but for me, I'm like really sensitive about things. Lost in the chaos was the following thought. You can divide rows, and you should. And if you watch that video, or if you decide this weekend or tonight or whatever to go back and watch it, you'll see dividing rows is a real big move because it enables us to shrink numbers and make our lives easier. So if you look at the top row, there's nothing that 3, 4, and 4 can all be divided by. And in the middle row, there's nothing that 5 and 8 can both be divided by. But the bottom row, those numbers can all be divided by what? 4. And I'm not saying you have to, but I'm going to. And I think it's worth the time. And so I would tell you this, and again, you know this if you watched it, you cannot, listen to me, you cannot, excuse me, you may not erase these numbers and put what they are. And the reason for that is because then I have no evidence as to where they came from. And when I'm sitting at home like a week from tonight grading your quizzes, and I don't see the 32 and the 20 and the 28, I just see some new numbers there, I'm just going to stop grading and put 0. I won't do it. I won't play the game. So as much as you might dislike this, you have to keep this row and then redo the matrix. That's just a courtesy to whoever, and any college teacher would tell you the same thing. We're not in the business of mind reading. So it takes about 30 seconds and you won't like it, but we do have to copy this matrix over because we're going to change a row. You don't have to tell me what that row operation is. If I see you doing something like this without a row operation defined, I'll know what you did. I'll figure that out. So the middle row is going to stay 0, negative 5, 1, and 8. And then the bottom row, I'm going to divide every number I see by 4. And that's not witchcraft. We've been doing that since 7th grade. It's an equation. You can divide both sides of an equation by whatever you want. So what do you want to divide it by? We could do 4 or we could do negative 4. You pick. Negative 4 will solve a couple of problems. You don't have to, but if we divide by negative, it'll turn them all positive, which is nice, right? Less stress. So we're going to divide this third row by negative 4. The 0 is not going to change. What's negative 32 going to become? Positive 8. What's negative 20 going to become? Positive 5. And what's negative 28 going to become?
Positive.
And I would arm wrestle or fist fight anyone who wants to debate this. That is worth the time. Our subsequent calculations that we have to do are just going to be more pleasant. So a little 30-second sidetrack, 100%. Sign me up. It's worth it. Okay. So we made it here and we accomplished objective 1. We put our zeros in the bottom of column 1. Do you remember what objective 2 is? And did you not change them? Good. I just wanted to make you switched them, right? Good for you. So our worker B this time.
Please get Sean Burnham to the office.
So our worker B this time is going to be the negative 5 row. All right. So that purple one, to me, my color Uh, my wife told me this the other day. She said, you should have a bucket of colored pens and tell your kids to take notes in pens. Is that a good idea? If I had like a bucket of color, would you guys use them if I had like you have your own pens, right? I thought about just spending $50 and getting a big bucket and see if anyone takes the offer. I don't know. I would use colored things if I took notes. Anyways, the purple thing signifies no touchy, but what we're going to do is we're going to first turn yellow guy into 0, and then we're going to turn bottom guy. I'll hold off on the colors for now. Okay. So the next step, remember, is leave a little bit of room and copy worker B row over. So we're going to copy over the 0, the -5, the 1, and then on the augmented side, we're going to copy down the 8. And now we have our worker B row all set in stone. What's the row operation that we're going to use between purple and red or purple and yellow to get top row to be 0? I like that. So um, -5 times row 1 plus 4 times row 2. That checks out. I like it. We're going to make a 20 and a -20. Sign me up for that. Okay. So we're going to work upwards now from purple row up to yellow row. And actually, you don't have to change this. I might be inclined to write those backwards. Just FYI. I like to put my worker B row first, but that's it. It's all going to come out in the wash. It doesn't matter. So if we work upwards now and we take 4 times this center row, we get 0. And then if we take -5 times this top row, we get -15. And what's 0 plus -15? So this does change. That number can change as long as, we're protecting the zeros. We need to do this in a certain way to protect the zeros. They are not something we want to mess up. So that's why we work in a very particular order. And of course, we know that 4 times the -5 and -5 times the yellow -4 are going to make, well, 0 because we planned that. That's not happenstance. Like we made that happen. All right, let's do it again. Take 4 times the number where I'm moving my pen. You get a 4. Take -5 times the number where I'm moving my pen. What do you get? And what's 4 plus 5? 9. It's massively meticulous work that we have to do, right? And then we're going to take 4 times the 8 where I'm moving my pen. That's a 32. And then we're going to take -5 times the number above it. And -5 and 4 make -20. And what's 32 and -20? See any nice thing about row 1? All divisible by 3. So we'll take advantage of that here in a moment, but do not put it there. Like I said, if you erase it and change them, I'm screwed. I got nothing. How am I going to figure that out? Right. And then it's time to head down to the red. And red, I like to just do it in the same order. So purple's worker, and then I hit yellow, and then I hit red. And so to make red be 0, what's the row operation that we're going to use? I'll start us out. I'll say we're going to do 8 times row 2 plus what? Good for you. If I multiply the purple number by 8, I get -40. If I multiply the red number by 5, I get +40. That's what I wanted to see. And then, of course, the zeros are going to just be, something times 0 plus something times 0. It's a whole lot of nothing plus a whole lot of nothing is still a whole lot of nothing, right? And we know what's going to happen where the purple or the red used to be. That's going to make another 0. So we're 2/3 of the way home. And trying to set a good example by writing numbers down here. I saw a couple pencils move when I did that the first time. It's not a bad idea. So if you take 8 times this 1, you get 8. If you take 5 times this 5, you get 25. Some brains are more powerful than others, and some brains are better at short term, like holding on to things like retention. I like to sometimes just write things down. Then when I get scatterbrained, I've got evidence of what I got. And what's 8 plus 25? So I'm going to put a 33 right here. Just see if you can answer this question. What are we hoping and looking for with the number that's right there that we don't know yet? If you can answer this, then you're not lost. Divide by what?
Right side of the.
Right. So a good number to get where that arrow's pointing would be 33. Another one would be 66. Another one would be 99, and so on and so forth. We want something that when we set up our little bottom equation and we divide that whatever it is divided by 33 ain't going to be something weird. So that's fingers crossed. So this is always a good place to stop. It's like your first opportunity to stop and say, how am I? It's like a kind of a milepost along the way. So same calculations again. We're going to take 8 times this row 2, which is 64. And then we're going to take 5 times this row 3. And 5 times 7 is 35. And as hoped for, we get 99. So again, you don't have to, but I think you're crazy if you don't. I personally right now would take this opportunity to clean up my matrix. I have numbers that are larger than they need to be. And so I'm going to take a quick moment and do a little house cleaning. What can every number in the top row be divided by? 3. We're going to do that one too. Absolutely. Yes, Kennedy, you bet. I want to make everything as small as I can. Every time before I have to do these annoying calculations, I want to shrink everything as much as possible. So my top row, if I divide everything by 3, I get -5, 0, 3, and 4. Perfect. These are the steps where, again, when I don't see where this green arrow is pointing, if I don't see a row operation there, I'm going to look to see that you must have divided a row or 2 by something, right? I'll figure that out. That's easy. Middle row does not change because there's no divisibility between 5 and 8. So we're going to just keep a 0, a -5, a 1, and an 8. And then bottom row, we're going to divide the living daylights out of that thing. We're going to divide them both by 33. Because we're already kind of done with that row, but it's nice since we have to use it now to not have it be a 33. All things being equal, if we divide them both by 33, we get a 0, a 0, a 1, and a 3. And 100 out of 100 people surveyed said they'd rather work with the matrix on the right than the one on the left. Okay. Which leads us now to our final matrix. Okay. So our last objective is to do what? Get the zeros above the worker bee. And the worker bee just works his way down. In step 1, the worker bee was up here. In step 2, the worker bee was right here. And in step 3, the worker bee is right here. So that number now is the one that will give of himself or use himself twice to make zeros to his north. And so now we have to figure out how to write the row operation. But by keeping our numbers small, I think we're making our lives a little bit easier. So I'm going to take a quick second and I'm going to leave about an inch and I'm going to recopy worker bee. So I'm going to do 0, 0, 1, and 3. That row is done. I'm going to take that one off the grill. Okay. So job 1, let's turn that yellow thing into a 0. Not quite as obvious as the one we did at the beginning of class 20 minutes ago, but still pretty easy. How do I make a 0 there? We're not using row 1 in this step at all. We're working with purple up to yellow. So yeah, so let's do negative. Let's do the, oops, sorry, I was writing it in the wrong place. Let's do the negative of row 3 and then work upwards and just add row 2. Does that work? You could phrase that differently, as long as you understand you're taking the opposite of one of them and adding them together. Like it's all going to come out in the wash. And so as I work my way upwards now, I just think in terms of opposites. The opposite of 0 is 0, and 0 plus 0 is, of course, 0. If that didn't stay as a 0, we're doing something wrong. The process is off. What's the opposite of 0 is 0, and 0 plus -5 is -5. The opposite of 1 is -1. -1 plus 1 is 0. What are we hoping for with this result? Something that can be divided by 5. So we're always checking for that divisibility since we're at the end now. And the opposite of 3 is -3, and -3 plus 8 is jackpot. And now it's time to go all the way up to red guy. Remember, you cannot, I keep saying can, you can, just don't, it'll break you. You may not use the yellow for your calculation. You will break a 0 and then you're hosed and you got to go back and figure it out. So do not work with what you create. Always work with worker B. What is the row operation that we'll use to make red equal 0? Yeah, and I'm going to just phrase it a little differently from you. I like to try to use my worker B row first. So I'm going to call it -3 of the row 3's upwards to an unmodified row 1. I like to do worker B first when it just feels like I can. So that's why I was a little hesitant 20 minutes ago with that first one. So we're taking everything in the bottom row and multiplying it by -3. And then we're adding upwards to, did I say that right? Up to row 1. So -3 times 0 is 0. Add it up to the unmodified -5, and that -5 does not change. Again, if this breaks a 0, it's because you're not listening. If you use yellow, you'll break the 0. But if we use this number, you cannot break that 0. Zeros, playing with zeros, just make more zeros. That's what we're going for here. So the opposite of 0 is 0, or -3 times 0 is still 0, plus 0 is, of course, still 0. And we know where this is headed because purple and red are going to make 0. Let's just verify that we didn't do something stupid. So -3 of these ones make -3, plus 3 makes 0. And what are we hoping for again? Something divisible by 5. The negative doesn't matter at this point. Like, who cares? It just needs to be divisible by 5. So -3 times the bottom is -9, and -9 plus 4 is -5. And we made it. So our final job, I mean, we're not done yet, but we have to understand that from this row comes this equation. -5x equals -5. Therefore, we know that x is equal to 1. From this row comes this equation, -5x equals, -5y equals 5. I was doing so well until there. -5y equals 5. So what does y equal? -1. And from our final row, nothing exciting here. We knew this 5 minutes ago. We just get z equals 3. And we're still not quite done. We need to write our final answer. And our answer is 1, -1, 3. That's how it's supposed to go. Not like that thing yesterday. You feel like you get it? Yeah, you can see why we probably want to use separate paper. So I'm going to give you the rest of this hour, and I'll probably give you some time tomorrow too. So it's 8:25. We get out at 8:38. That's 13 minutes today. I don't know if you can maybe get another one done or close to done. That'd be pretty rad. I'll pause this. These are usually, if you say like, I have a question, it's going to be a matter of me looking at your paper. Because then it's don't be hasty. Like, don't expect if you say I did something wrong for me to look at it like I usually do and go, there it is. It takes time. So you try to be on your A game as much as you can, because I'm happy to help, but these take a long time to find mistakes if you make one, which, as I demonstrated aptly yesterday, is very possible. So good luck.